Hello students, this is a video on the topic tests that we have for you. So these topic tests are designed in a way where you can test yourself once you've completed the basic concepts of a topic. Once you give the test, that is when you look at this video to get an idea of what could have been a decent attempt, which questions to look at, and the overall difficulty of the test. There are more than 200 such topic tests available on the Bodhee Prep Android app. The link for the app is in the description of the video. So download the app and use these tests to strengthen your preparation. This video specifically is about number systems. Subtopic means being properties of numbers, and this is test number 3 as per the app. Now, if I go into the test analysis overall, I think this was a moderate level of difficulty paper. And for a 95%, I think 6 questions net correct should be a good attempt. Attempt time would probably be somewhere around 22 to 25 minutes. Now, what happens with number system questions is if there are questions where you're supposed to make cases and sometimes even generic questions where the starting point becomes a little difficult to spot, those questions tend to eat up time. You might not be able to do them, but that thinking process takes a lot of time. And therefore, for these questions, when compared to an arithmetic test, the attempt time might actually be higher, right? And therefore, maybe 25 odd minutes should be a good attempt for overall questions. And in that, try to get about 6 questions net correct. If you look at the questions, the first says, n is a natural number less than 100. N is a natural number less than 100, so something between 1 and 100, including both. Less than 100, 100 is not included. Less than 100. So 1 to 99 basically. How many values of n, for how many values of n are the numbers 6n plus 1, 15n plus 2 relatively prime to each other? And therefore, we need values where 16n and 15n plus 2 should have a common factor, which is not 1. If that happens, they are not relatively prime, otherwise they are prime. So we want a common factor. Now we work with the coefficients of n. Here it is 16, here it is 15. We try to make them same. If I multiply this by 5, I get 30n plus 5. If I multiply this by 2, I get 30n plus 4. So this is into 5, this is into 4. Now, 30n plus 5 is divisible by 6n plus 1. Suppose the factor of 6n plus 1 is x. So 30n plus 5 should be divisible by x. Similarly, 30n plus 4 is divisible by 15n plus 2. If the common factor between 6n plus 1 and 5n plus 2 is x, then 30n plus 4 should also be divisible by x. But we can see that they are consecutive numbers. Something plus 4, something plus 5. So difference is 1. What can be the common factor of two numbers which have a difference of 1? The common factor will be 30n plus 5 minus 30n plus 4, which is 1. So the common factor will be 1. And therefore, for any value of n, 16n plus 1 and 15n plus 2 will have a common factor which is 1. And so they will always be relatively prime. So for how many values of n? For all values of n from 1 to 100, and therefore none of these becomes the answer. In terms of level of difficulty, I'd say easily a moderate and maybe even higher level of difficulty. 2.5 minutes should be 2.5 to 3 minutes should be the time where you're able to crack the 16 and 15 connection and then work from there. Can also be attempted by putting values. So if we start putting, but again, since one of the options is 33, becomes a little difficult to be sure. But even putting values of n as 1, 2, 3, 4, 5 might lead us to an answer. N is a multiple of 12 greater than 999 and less than 10,000. So basically, n is a 4-digit number, multiple of 12, such that when n is divided by 100, the remainder is same as the quotient. How many possible values can n assume? So the remainder is same as quotient. If we divide anything by n, anything by 100, the last two digits are the remainder. So suppose the remainder is AB, the quotient will also be AB. N is of the form AB, which means it is AB00 plus AB. If we divide this by 100, quotient will be AB, remainder will be AB. So basically, a number of the form AB is what is required. Also, this has to be divisible by 12, so divisible by 4 and divisible by 3. Sum of digits is 2a plus b. This should be divisible by 3, and the last two numbers should be divisible or should be divisible by 4 as a number. So what we do is AB. If we have 0 4, it will not work. 0 it will not work. A cannot be 0. So we write multiples of 4. 12, 16, 20, 24, 28, 32, 36, 40. There will be a lot. Okay. Also, we can check for 3 simultaneously. The sum a plus b has to be divisible by 3 because the sum of digits is twice a plus b. 2 is not divisible by 3. So the sum has to be divisible by 3. For example, here 1, 2 is divisible by 3. So 1, 2, 1, 2 will be one such number. 1, 6, 7 is not divisible by 3. So this will not be a number. 2, 0 is not divisible by 3. So not a number. 2, 4 is divisible by 3. Therefore 2 plus 4. So 2, 4, 2, 4 becomes another number. 12, 24. And therefore the next number will be 36. So basically we're just looking at multiples of 12. 36 will work. So 3636. The next number will be 48, 4848. Then 60, 6060. 6060. Then 72, 64 will not work. 68, 14, 28. 72, 7272. And therefore they are basically all multiples of 12 itself. 8484, 9696. The coefficient and remainder will be same. Therefore, 1, 2, 3, 4, 5, 6, 7, 8. N can assume 8 values. Again, in terms of level of difficulty, I think because 12 and we just were looking for multiples, maybe easy towards moderate level of difficulty. 2.5 minutes should be good enough to answer this question. P, Q, R, S, T, U, V, W, X, Y. 1, 2, 3, 4, 5, 6, 7, 8, 9. Is a 10-digit number with distinct digits. Therefore, the values of 0 to 9 will be used for these 10 digits. P is greater than Q is greater than R. S is greater than T is greater than U, decreasing order. V is greater than W is greater than X is greater than Y. So the first three are decreasing, S, T, U are decreasing, and last four are decreasing. Amongst themselves, we do not know. STU are consecutive even digits. STU are consecutive even digits. Even digits are 0, 2, 4, 6, 8. So 0, 2, 4, 2, 4, 6, 4, 6. Three cases are possible. WX are consecutive odd digits. Odd digits are 1, 3, 5, 7, 9. So if you look at PQR, STU, VWXY. PQR, STU, VWXY. If they're consecutive odd digits, they will be 1, 3, 5, 7 or 1, 2, 3, 4. 3, 5, 7, 9. This is the only possibility. These are the only two possibilities. PQRSTU 3, 5, 1, 3, 5, 7, 3, 5, 7, 9. Consecutive odd, consecutive even. Now here we need consecutive even. STU can have three values, but we need PQR as 9. In this case, we will have 9 remaining. In this case, we will have 1 remaining. If PQR is 9, then one of them is 9 because 9 will not be amongst STU. So one of the values 9 has to come here. Now this plus this cannot be 9 because then this have to be 0, 0. This is not the case. The case we have is last 4 digits VWXY 9753 and therefore one of PQR is 1. Also P is greater than Q is greater than R. So if 0 comes here, then there is other case. So 1 will be one of these digits. We want the sum to be 9. Now, if we look at the possibilities for STU, they can be 0 to 4, in which case we have 6 and 8. 6 plus 8 plus 1 is not 9. Next is 2, 4, 6, in which case we get 8 and 2. 8 and 2. 8 and 8 and 0. In this case, 8 plus 0 plus 1 is 9. So this is a possibility. 0 to 4 consecutive, even 2, 4, 6 or 4, 6, 8. In which case we have 2, 0 and 1 left, which is again not 9. So for this case, we get all the numbers correct. Last 4 digits become 3, 5, 7, 9. STU become 2, 4 and 6. And therefore we have 8, 1 and 0 left for PQR. In descending order, they will be 8, 1, 0. All the conditions are satisfied. P is greater than Q is greater than R, S is greater than T is greater than U, V, W, X, Y, S, T are consecutive even 2, 4, 6, V, W, X, Y are consecutive odd 3, 5, 7, 9, P plus Q plus R is 9. What is the value of R plus S plus T? P, Q, R plus S plus T. 6 plus 4 plus 0 is 10, option C. I would say an easy to moderate question, not about, if you're solving this, maybe about 2 odd minutes to solve should be good enough. Because we start with the odd case, there are 2 cases, out of which 1 is eliminated, and then we just have to put 3 values. A game consisting of 50 rounds is played amongst P, Q, and R as follows. 2 players play in each round, and the player who loses in that round is replaced by the third player in the next round. So if P and Q play, next game will definitely be played by R because one of them will lose, and so on. If the only rounds in which P played against Q, so PQ happened in the third round, PQ happened in the 14th round, PQ happened in the 25th round, and PQ happened in the 36th round. Then what can be the maximum number of games won by R? Now clearly, because third round is played between PQ, in the second round R would have lost to either P or Q. So the winner continued, and then and then the other person joined. So second round would have been lost by R for sure. In the 14th round, since P and Q are playing, so in the 13th round, again R would have lost to either one of P or Q. Similarly, in the 24th round, R would have lost to someone, either P or Q. In the 36th round also the same thing, 35th round also the same thing would have happened. So clearly R will have to lose second, 13th, 24th and 35th round for the next rounds to be P and Q. R cannot win these 4 rounds. Also R cannot win the third, 14th, 25th and 36th round because R is not playing these rounds. So definitely these 8 rounds will be lost by R. So maximum rounds that R can win is 50 minus 8, which would be 42. Again, level of difficulty wise, I'd say easy to moderate. 90 odd seconds should be good enough to get this question done with. If x is 10 raised to power 20 minus 9 raised to power 17 upon 10 raised to power 14 minus 9 raised to power 11, which of the following is true? The difference between 20 and 14 is 6, 17 and 11 is 6. Okay. Now, if we look at 10 raised to power 20, or if we look at, say, y, and define it as 10 raised to power 14 minus 9 raised to power 11 upon 10 raised to power 14 minus 9 raised to power 11. So essentially y is 1, multiplying this by 10 raised to power 6. We will get 10 raised to power 20 minus 9 raised to power 11 into 10 raised to power 6 upon 10 raised to power 14 minus 9 raised to power 11. This is the value of 10 raised to power 6. Now, if we look at this term, 10 raised to power 20 upon 10 raised to power 14 minus 9 raised to power 11 minus 9 raised to power 11 into 10 raised to power 6 upon 10 raised to power 14 into 9 raised to power 11 minus. The negative term is 9 raised to 11 minus into 10 raised to power 6. So we can say this will be smaller than, this term will be smaller than 10 raised to power 20 upon 10 raised to power 14 minus 9 raised to power 11 minus 9 raised to power 11 into 9 raised to power 6 upon 10 raised to power 14 minus 9 raised to power 11. So basically what I'm saying is, in the negative term, we had 9 raised to power 11 into 10 raised to power 6. 10 raised to power 6 is greater than 9 raised to power 6. So if the negative term, we replace 10 raised to power 6 by 9 raised to power 6, we will get a larger term. So basically, 10 raised to power 20 minus 9 raised to power 11 into 10 raised to power 6 upon 10 raised to power 14 minus 9 raised to power 11 is less than 10 raised to power 20 minus 9 raised to power 17 upon 10 raised to power 14 minus 9 raised to power 11. This is the value of 10 raised to power 6. So 10 and this is the value of x. Therefore, we can say x is greater than 10 raised to power 6. Option D becomes the answer. Then I think moderate level of question. 2 minutes should be good enough to answer the question. What is the largest prime factor of 3 raised to power 12 minus 1? Now, typically when even powers are there is a negative term in a binomial. A good way of going about it is splitting it into a square minus b squared. So this can be written as 3 squared raised to power 6 minus 1 raised to power 6. So this is nothing but a squared minus b squared. Oh, sorry. 3 raised to power 6 squared minus 1 raised to power 2. Order was different. So this can be written as 3 raised to power 6 minus 1 into 3 raised to power 6 plus 2 plus 1. Further, 3 raised to power 6 plus 1 will be an even number. 3 raised to power 6 odd plus 1 will be even. 3 raised to power 6 minus 1 can be written as 3 raised to power 6 becomes 3 cube square minus 1 square. So this can be written as 3 cube minus 1 into 3 cube plus 1. 3 raised to power 6 will be 3, 9, 27, 80 or 729, 730. 3 cube will be 3, 9, 27 minus 1, 28. 3 cube will be 27 plus 1, 20, 27 minus 1 is 26. 27 plus 1 is 28. So this is what we will get. 730 can be written as 73 into 2 into 5. 26 is 13 into 2. 28 is 7 into 2 into 2. And therefore the largest prime number, largest prime factor of the expression comes out to 73. Just broken down the term into smaller numbers and then work from there. I think moderate level of difficulty once you start breaking down the numbers, especially because the power is not very, very high. We should get the terms. 2 minutes, 2.5 minutes should be good enough to answer this question. A basket contains only 3 kinds of fruits. Guavas, mangoes, and pears. What is the minimum number of fruits that should be picked from the basket to ensure at least 5 guavas or at least 7 mangoes, or one of these things has to happen, at least 8 pairs. Suppose we end up picking the worst case scenario. So the first 4 fruits that we pick up are guavas. The next 6 fruits that we pick up are mangoes. And the next 7 fruits that we pick up are pears. Now, when this happens, we have picked up 4, 6, 10, and 17 fruits, and none of these conditions have yet been met. So, one less than the condition required. If we take the sum of all the cases, with 17 fruits, none of this has happened. The moment we pick up the next fruit, at least one of the condition will get filled or will get fulfilled, and that is what we want to do. So, when we pick 17 plus 1, 18th fruit, we can be sure at least one of these conditions has been fulfilled. So what is the minimum number of fruits that has to be picked up to be sure? To be sure, 18 fruits have to be picked up. It is possible that the condition is happens in the first 5 fruits as well. The condition happens in the first 5 fruits itself. The first 5 fruits that we pick up are guavas, but we cannot be sure. But when we have picked 18 fruits, we can be sure that at least one of the conditions has been fulfilled. So 18 becomes the answer. I think easy question, especially because of the fact that such questions you would have come across during practice, should be done in maybe a minute and a half. A is root of 8 minus root of 7 upon root of 8 plus root of 7. B is root of 8 plus 7 and minus 7. Okay. They are reciprocals essentially. We have to find the value of 1 by a plus 1 by b upon 1 plus 1 by ab. 1 by a plus 1 by b upon 1 plus 1 by ab. This becomes b plus a upon ab. B plus a upon ab upon ab plus 1 upon ab. This will be ab cancel, b plus a upon AB plus 1. Okay. Now, if we find out, if we look at AB will be nothing but root of 8 minus root of 7 upon root of 8 plus root of 7 into B, root of 8 plus root of 7 upon root of 8 minus root of 7. Since they are reciprocals, as is clear by just looking at the terms, A into B will simply give us 1. This cancels out, this cancels out, AB is 1. This becomes 1 plus 1. Now we have to find out B plus A. B plus A will be root of 8 plus root of 7 upon root of 8 minus root of 7B plus root of 8 minus root of 7 upon root of 8 plus root of 7. Take the LCM by multiplying. This becomes A plus B into A minus B, root of 8 square minus root of 7 squared. In the numerator, we'll have root of 8 plus 7, root of 8 plus 7 whole squared. So 8 plus 7 plus 2 into root 8 root 7 plus we'll have the square of this, the root of 8 square. 8 plus 7 minus 2 into root of 8 root of 7. So this further becomes 8 plus 7, 15, 15, 30. The positive negative term cancels out. 15 upon 8 minus 7, which is 1. So B plus A is nothing but 1, is nothing but 15. Sorry, 8 plus 7, 15, 15, 30. I'm really sorry for this. The last step here. We'll get 8 plus 7, 15, plus 15, which is 30. Positive negative term cancel. Root of 8 square is 8 minus 7, 1. Hence, B plus A is 30. So here we write 30. So overall value that we get is 30 upon 2, which is 15 becomes the answer. The simple question on surds. If we know how to rationalize surds, we will be able. We don't have to rationalize it because by default it will happen once we add A and B. But again, maybe 120 odd seconds at most to solve this question definitely should be done in exams if it does show up. N is a natural number of at least 5 digits and its leftmost digit is 6. At least 5 digits. So let us take the case for 5 digits 1, 2, 3, 4, 5. Leftmost digit is 6. When 6 is removed from N, A, B, C, D, so we'll be left with A, B, C, D. When 6 is removed from N, the number thus obtained is 1 by 25 times of N. So upon 25. What is the sum of digits of N? So 6 ABCD or is equal to 25 into ABCD. Then we have at least a 5-digit number starting with 6. If we remove the 6, 4-digit number ABCD remains, and that is 25 times that will be the original number. We have to find the value of the sum of digits of N. This is B not B. Now 25. The last digit D. Anything multiplied with 5, D will give me 5 or 0. 0 is possible. 25 into 25 is 625. If we add a double 0 here, we'll get double 0. This could be one of the cases. 62500 upon 25 will be nothing but 2500. So one of the numbers could be 62500. If we add the digits, gives us 6 plus 11, 6 plus 13. This is a valid answer that will work because this is a sum that can be determined. If you want to be sure about this question, definitively solve it. What we can do is, see, this term can be written as 60,000 plus 1000A plus 100B plus, or we can write it as, yes, 60,000 plus ABCD, where ABCD is a 4-digit number. This should be equal to 25 into ABCD, where ABCD is a 4-digit number, which means 60,000 is nothing but 25 minus 1 into ABCD. ABCD, which means the 4-digit number ABCD is nothing but 60,000 upon 24. 600 upon 24 is 25. So ABCD will become 2500. 2500 is this number, and therefore the original number will be 62500. Either we solve it like using the equation, or if this hidden trial strikes where you remember that 25 into 25 625, the digits are repeating, even that will give you an answer. In terms of solving the question outrightly, I'd say it's a difficult question because the numbers may not strike. Once they do, solving it may not be very difficult, but on its own, I think a difficult question. A four-digit number is such that the sum of the first two digits, A, B, C, D, is the four-digit number. Sum of the first two digits, A plus B, is equal to the sum of the last two digits, C plus D, while the sum of the first and the third digits, A plus C, and is equal to the last digit, which is D, C plus D. If sum of the first and the last digit, A plus D, is thrice the sum of the second and the third digit, thrice of B plus C, which of the following can be the second digit of the number? Okay. A plus B is equal to C plus D, A plus C is equal to D. If we subtract equation 1, equation 2, equation 3, if we subtract 1 from 2, A minus A is 0, B minus C is equal to C, D minus D is 0. So B is equal to twice of C. B has to be a multiple of 2, so 1 and 5 are not possible. Okay. B is equal to twice of C. If we substitute B in all the equations, or at least in the two equations, here we can say in the first equation, A plus 2C is equal to C. We get the second equation, not necessarily. Substituting it in the third equation. A plus D is equal to 3 times of 2C plus C. So A plus D is equal to 3 into 3C, which is 9C. Now, if C takes a value of 1, A plus D will be 9, which is possible. If C takes a value of 2, A plus D have to be 18. The only case then is, if C is 2, A and D both have to be 9 and 9. And B has to be 4. In this case, if we look at it, A plus B is not equal to C plus B. And therefore, this case is not possible. So C has to be 1. B therefore has to be 2. And that is the answer to my question. But if we are trying to find out all the values and be sure that this is actually the case, A plus D is 9 and A plus C is equal to D. A plus 1 is equal to D. So if we substitute D as D is equal to A plus 1 here, we get A plus 1 is equal to 9, 2A is equal to 8, A is equal to 4. So 4, 2, 1, A plus 1 is D, so 5. The sum of the first two numbers is the sum of the last two numbers, 4, 2, 1, 5, 4 plus 2, 6, 1 plus 5, 6. A plus C, 4 plus 1 is equal to 5. A plus D, 4 plus 5 is 3 times 2 plus 1, and therefore B is equal to 2. A and D, we did not have to find, but anyways, overall, if I look at this question, I'd say easy to moderate. 2.5 minutes at most should be enough to get this question correct, even if the first relationship between B and C does not appear quickly, and we work with the equations. Even then, 2.5 to 3 minutes will be sufficient to answer the question. And therefore, if I look at the overall test, overall moderate level of difficulty, 6 questions should have happened for sure for a 95 odd percentile. 20 to 25, 22 to 25 minutes. Again, on the higher side, 25 minutes to solve the test. The 6 questions that I would have attempted would be 2, 3, 4, 7, 8, 10. Which are these? Again, not counting this for the simple reason that 6 and 15 connection might not be able to spot directly. Definitely doing this, just looking at multiples of 12. Definitely doing this, limited cases to be formed. Would have done this as well, because just 2 points to figure out here that Q cannot win a game. R cannot win a game between P and Q, and R has to lose to get out. So remove those games. May not strike every time in the examination, so not counting this as a attempt question. Again, the power was small, but if I have to choose 6 of the easiest questions, this might not make the cut for me. Would have definitely done this every single time. This was also a very easy question, should have been attempted. This I will not count as an attempt question because there might be a case where confusion might happen and the equation might not strike. Would have done this every single time because there were just 4 digits. So even if it takes time, I'm sure the accuracy will be high in such a question always. And therefore 2, 3, 4, 7, 8, 10 becomes my attempt for this test.